Each year, Microsoft Research hosts hundreds of influential speakers from around the world, including leading scientists, renowned experts in technology, book authors, and leading academics, and makes videos of these lectures freely available.
Welcome to the first broadcast from this particular room at Building 99. And I should probably tell people out there who are listening today, if they are lucky enough to be listening now, that we're having our open house for the building today at 4 o'clock. And I think I'm okay to invite anybody who sees this talk to come over to the open house at 4 o'clock in our new beautiful atrium here at Building 99. So we're honored today to have Professor Austin Tate here with us, all the way from Scotland. He holds the chair in knowledge-based systems at the University of Edinburgh and is the director of the Artificial Intelligence Applications Institute at the university. And he helped form that institute way back in 1984. And it's a well-known organization for having the insight and the ability to take some insights from academics and to transfer them into some real-world applications, both in the government, public sector space, as well as the commercial space. Austin received his PhD at Edinburgh in machine intelligence, working with Donald Mickey in 1975. He finished that work, and he is a fellow of the Royal Society of Edinburgh, so Scotland's National Academy. And he's a fellow of the Association for the Advancement of Artificial Intelligence. I serve with him on the advisory board for IEEE Intelligent Systems Journal, and he's quite involved in the academic community, serving on the boards of a number of journals. He's here today visiting with several different groups of folks at Microsoft, and on Monday as well. Right now he'll be speaking about iRoom, Intelligent Collaborative Spaces for Emergency Response. So Austin, why don't you come on up?
Thanks, Eric. So thank you for inviting me along to speak to you folks at Microsoft. I'm very pleased to be here. I'm going to take you through some of the work we've been doing in intelligent planning technologies over the years. I'm going to show you some of the roots of the research work we've been doing at Edinburgh in this area, some of the applications that that's led to, give you a feeling for where the heart is of the work I'm going to talk about. But then I'm going to really rather rapidly move forward into collaborative systems, especially for emergency response. And just recent work we've been doing, which has been taking that into virtual collaboration centres that can be rapidly stood up when emergencies occur, but using a lot of this background planning, AI planning, and collaboration technology. So we're going to do a really rapid overview of a lot of that. The aim is to give some background to the people I'm hoping to be able to speak to here about some of the projects you're doing at Microsoft, which I do believe are a conduit for delivering some of these concepts. And it's the concepts behind what I'm describing here that I'm here to talk to Microsoft about. Not the systems, not the technology, not the application specifically, but the underlying concepts that are here. And that's what I'm hoping you'll see in this really rapid run through things. So let's make a start. So we're going to quickly look at the background that we've got in AI planning and what we've been doing and where it's been delivered. Then look at its application in some of our research projects over the last 15 years in particular in emergency response. I've been concentrating on emergency response. I actually want to make a difference with emergency response systems, and I believe this technology is well suited to that. Then I'm going to give you a very quick overview of IX technology. Some of your colleagues I'm speaking to this afternoon, we're going to go into a bit more detail with that, and I'm hoping to give you a little more of a flavour, especially on the architectural side of where we're coming from and why the abstractions we believe are important and long-lived. And then a little bit about virtual worlds technology and how we're merging these with into a project we call iRoom. Just to give you a flavour of this, we've been working on these planning technologies for 30 years. Eric just mentioned I got my PhD with Donald Mickey in the area of planning and search technologies right back in '75. And Nonlin was created in 1975, which was my first major planning system. It's still used as one of the textbook examples of AI planning systems that are hierarchical in nature. Over a 20-year period, we then worked on a technology called OPLAN, Open Planning Architecture. And OPLAN's the core of what we now have as our new technology, which we call IX, just stands for Intelligent Technology. INCA is the ontology or the conceptual model that underlies that. And we'll come back to that in a second. And then we've used this as a basis for a wide range of collaborations, projects and applications that we've been working on, including student projects and international projects. Our focus of the last decade, as I said, has been on emergency response, and we cluster this together now into a vision we call the helpful environment. And I'm going to try to elaborate that vision to you. So just to give you a flavour of some of the technologies that have gone into application use, going right back to 1975 with Nonlin, it was actually used with our electricity utilities in the UK for turbine overhaul procedure, maintenance procedures, very expensive procedures. So we were already looking at applications right at the start of my career, and I consider myself to be an applied researcher in the way I approach research. The Nonlin system was taken up by Steve Veer at JPL and became NASA's first AI planning system. They've got a really strong planning group at NASA. Planners have been flown on spacecraft and used live to control spacecraft. Really good groups there. But the very earliest of the planners was used to model the Voyager mission after it had flown, so it was just an after event modelling. But it's a very nice piece of work that they did to create something called the Divisor Planner, and the core design of that is based on Nonlin. More practically, we then re-implemented the Nonlin O-Plan technology with a set of spacecraft engineering companies for the Ariane assembly, integration and test procedure. So it is in use for Ariane launches and for Ariane assembly, integration and test at Kourou. And then recently, as I said, we've been using it with the UK and the US emergency response forces for personnel recovery and search and rescue. And over the years, it's been involved in the core of robot design systems, in financial help desks. It's in use as a part of the design of some of the financial help desk systems that you see in use across the world, and in things like scheduling tanker delivery and so on. There's quite a lot going on there. This is our vision. The creation and use of task-centric virtual organizations. We want to make task-oriented organizations, one interested in performing tasks. And we want to create these organizations rapidly from a range of things in the environment, a range of potential resources. And we want to do that to respond to very dynamic events as they occur, on all scales, from very local, helping you in your home or your vehicle or your office, right up to truly international major responses internationally. That's the vision for my research group. That's our mission statement, if you like. Now, to do that, we want to be exploring a lot of these things. And some of them are technological, some of them are society and organizing ourselves as populations in terms of building codes and organizing the way we have helpful organizations that respond internationally. I won't try to go over this. This is just a list of some of the technologies orientated towards my interest in artificial intelligence that could contribute in these areas. There's massive opportunities for research, development, and really making a difference if we pull on a lot of these technologies. And the Japanese saw some of this with their vision for a 50-year program in rescue robotics, which is well underway now, and in systems which could respond on an international level to these kind of emergencies. This is a diagram out of a paper by Gitano and his colleagues on RoboCup rescue. It shows lots of things that could come together from what you're doing in terms of sensing the environment. Let me just put these on. The environment itself, and what you could gain from the environment if you had better sensor grids, better ways of understanding what's going on in the environment. Then the people and organizations that can organize themselves to do that, and the societal ways in which that could occur, and then the systems that could be layered on that to assist. And this is a big, big vision, a broad vision of lots of contributory elements that scientists, engineers, companies, organizations, governments could do if they all got together and understood that they could create these kind of large-scale visions of how you could have emergency response. And it's meant to cover all this cycle of collecting data in the environment, understanding when, patterns are coming, water patterns are coming across the Pacific, and it might be a tsunami, and sensing that early enough that you can actually put it into systems which can help you simulate, help you understand what might happen, get ahead of the of the sensors and understand in a super real time what might happen, get that to decision makers who can start to do something about it, mobilize resources, potentially get to the people who can save lives. This is the vision that they had for the 50-year RoboCup rescue, and it's embodied in the kind of aim I just stated. So we've been working on that sort of thing. We've been trying to make some of it happen through our research projects and trying to communicate that exactly at events like this. That's why I'm delighted to be able to give this talk. to make sure people are aware of what's possible and perhaps understand some of this vision is going to be a shared vision that we can all make come about. So I'm going to go over some of those projects you see there as we rip through this talk with some of the slideshow. I'll give you a flavour of what's there. Of course, as usual, almost all the detail of this is on the web. Every one of these projects has its own website. There's lots of material there, and our papers are all clustered together into the document areas of these websites. So just a quick bit of technology that's underlying this so you can see where we're coming from and what we've been doing ourselves. So IX technology, we just call it intelligent technology. It's based on the O-Plan core design. So it is an open planning architecture, but it's been generalized to be relevant to a wider range of what are called synthesis problems. And you'll see that in a minute. It has a systems integration aspect, so it has an architecture. It has a representation aspect, so it has a core, central, conceptual model, very simple conceptual model that's meant to underpin what it does. It allows for the plugging in of reasoning capabilities, whether human or system. It can support user interfaces, and we do explore some of those in our research, and it allows for lots of applications and tools. So this is what it looks like. We assume a world of collaboration and communication. We're not researching that ourselves. So we're overlaying onto what we believe will be ubiquitous communication and collaboration environments. But we're then wanting to support people who are involved in command centers, decision-making centers, in higher level central authorities who you may have to communicate to get serious senior decision-making or to get the context within which command authorities can work. And remember, these might not be, we're not just talking about military here, this could be anybody taking command decisions or executive decisions at any level. Also the responders or the people out in the field or the individuals who are being harnessed together to help in these kind of environments. And then the people who are having the problem, the people in the building who are potentially isolated, or the people out on a ship or on a mountain that are needing rescued. So the idea is to see all these as a community that you're trying to bring together as best you can to respond to an emergency. And our technology is intended to try to assist in doing that. The IX approach is very simple. It involves the use of shared models for task-directed communication between humans and systems. It basically has just two cycles: handling issues as they come up, treating things as issues to be addressed, and managing your understanding of the world, i.e. the constraints on that world, where they come from, why they should apply, or why they may be relaxed. So it is about handling issues and managing constraints. And then the idea is that an IX system or agent, whether this is a person doing this manually, or whether it's a computing system, or whether it's a mix of those, really carries out a process which leads to the production of some sort of output, some sort of product. So all you're doing is saying, we have a process that produces a product. Now, that process may not yet be known or determined, so it may be dynamically determined. You may have to create the process, indeed, to be able to create a new novel product. And that the product itself may also not be defined. So you've got the problem of defining the product, defining the process, and then finding ways to do that. And of course, you want to do that collaboratively between people. So an IX system or agent, individual agent, views a synthesized artifact as being represented by a set of constraints on all possible artifacts in that domain. So what you're doing really is trying to find constraints on one object in the domain of discourse. So you have to find a way of describing that domain, constraining it, and then finding processes to get to that point. That's all the formal aspect of IX is. And then the rest is how you elaborate that to make good systems. The conceptual model behind it we call INCA, and it's a generalization of plan representations that have been around a long time. It didn't just come from our research. It's an amalgam of a lot of research in a lot of different fields. And indeed being involved in a lot of standards activities, like in things like the NIST process specification language, which is a standard. It's now an ISO standard. It was a NIST standard, and that is used for manufacturing process definition, for instance. We were involved in that team. So the NIST PSL work and other kinds of standards work have all influenced the way we see we've created these models. So INCA, as I said before, is a common, because the IX architecture also has this same aim. It's a common conceptual base of sharing information about processes and the products of those processes. It's intended to be shared, intelligible to humans and machines at some level, easily communicated, and it can be formally or informally represented. Very intended to be extremely extendable. it's based on 4 core concepts. Issues, which are meant to be expressed in question terms, questions to be addressed. So events occurring can be thought of as transformed into questions to address about those events. That's typically the way you would start off handling things, in other words. You'd have a set of issues, and then you start to work on how you address those. A set of nodes, which are going to be the heart of what you're designing as the process model or the product model. You'll see in a minute that they typically, in the case of plans and processes, will be activities. In the case of a design, it might be the parts of a product, like a parts of a car if you're designing that. Then the set of constraints, which are meant to be open-ended, set of all sorts of constraints on this space of artifacts that you're creating. And then, importantly, a set of annotations, which can be used to capture a lot of the rationale behind things, notes, reports, progress, you name it. All sorts of information can then go into it. So these annotations are meant to be structured things. They're not just meant to be arbitrary notes. These 4 things are then supported by reasoning mechanisms which reason over the 4 things. So issue-based sense-making is used from things like the GIBIS community. This is a generalized issue-based design community, used for things like, creating a Boeing aeroplane or something like that. They use these kind of issue-based design methods. So this is a big community that's been working for years on issue-based design. And more recently, the researchers in that field have elaborated 7 ontologically separate types of issue that you can address. Knowing there are those 7 can assist you in structuring the way you respond, because you can have regular response methods. And then bringing in activity planning execution, which has been my route, as you saw in the earlier part of the talk. Then constraint satisfaction, which has been a very successful area of operations research and AI. There's lots of very successful constraint satisfaction methods, search-based methods, constraint satisfaction systems, and so on. So that gives an opportunity to rapidly constrain these spaces, search those spaces, come up with solutions or sub-solutions in those spaces, and assist people with it. This is a great area for computing technology to help in these kind of systems. And then note-making, rationale capture, and so on. That's the Inca framework. Then alongside that, you maintain the status of current, you have some model of the current state, status of objects in the environment, status of people in the environment, and things like that kind, but also your other models and knowledge. And then we use this technology, software technology now, called IX process panels, to represent and reason over all of these objects. So the idea is to use the current state to try to represent context-sensitive actions to respond to the things that are coming onto the list, like the issues to be addressed. So the idea all the time is to try to get options for action in this constrained space dealing with the issues. And what we try to do is to have this model, mixed initiative model between systems and humans, of mutually constraining things. So there's a single underlying principle, which is that everybody is trying at some level of abstraction to mutually constrain things. Whatever they're doing can then be presented that way. So IX process panels look a bit like this. This is a very dry sort of way of presenting it. There's a set of issues, a set of activities, some state model and some viewers and some annotations. But we don't really expect this to be the way you would present this to your users. You would present through desktops and through dashboards and other things that were relevant to them. If you're in a command center, you would have elements of the display that would be supported by this. But this is the kind of software technology we use to get to the core of what's going on in the Inca. And then we register viewers. In fact, all these are just registered viewers for these things. And you can register many other kinds of viewers. So the process panels there are just showing really it's the kind of sophisticated to-do list. It's a structured to-do list. What you're trying to do all the time is populate this column. So when you say, what can I do to address, let's say, that activity or that issue? It's trying to populate it with a set of actions you could perform now or in the future that are relevant to that. So it's meant to be a context-sensitive list of what you can do, given the current state, the current position you are in the model, the current constraint set. Some are grayed out because they're not possible yet, but they could become possible. Others are ready to go, which is the orange, and so on. So the idea, and some of this will be dependent on the status of other agents, other capabilities, other services that you can call on. So that's the action pop-up. And then we register a number of different viewers on this. There's editors. There's a little planning tool behind that can complete these plans rather than you going through them manually. It fits the messaging technology, something I'm hoping to be talking about with your colleagues this afternoon, about how this fits naturally into a kind of structured or intelligent messaging kind of framework, so it can fit alongside messengers in social networks and environments. You can register whiteboards, you can register map tools and things of that kind instead of these rather simple text-based views. So that's the software technology we work on to animate the model I just mentioned before. And the aim of these process panels is to be a catch-all for doing things in this Inca world. So when you've got these things represented by Inca, these shared processes, these shared artifacts, then the aim is that you can take anything that's thrown at you. If people raise issues, if people want you to perform an activity, like a to-do list kind of thing, or they want you to check or respect a constraint, or they tell you a constraint on what's going on, or they give you time constraints, or spatial constraints, or authority constraints, or they give you notes, and they give you reports, and they give you partial completions, they give you failure information. It's meant to be able to take any of those that's thrown at it, and then to deal with those by dealing with them manually. So a simple example of this could be your to-do list manager on your PDA. You could just have activities coming in, it would put them on, you could manually tick them off. That would be an Inca system in that sense, a very simple one, but it could be presented that way. Because you're doing manual activity of ticking things off when you've done them according to these. But you could imagine that you could also put very simple temporal constraints on when you can do things that said, well, you can't tick that off yet because you definitely haven't done those 3 things in advance. And we insist you do, rather than it's optional. Then all of a sudden you've constrained what you as a user could do in the interface, and then you're starting to use a little bit more of the potential representation behind this. And you won't be surprised to hear that we've worked with companies who have designed very, very flexible PDAs intended to be a kind of a more of a manager of plans than literally a to-do list. Because you want to deal with things that are much more ephemeral than, and more flexible in terms of the time management and so on in that respect. But you can also use internal capabilities as well as manually now. You can say, do it that way. So something on your to-do list, and you say, and a way of doing it would be to pass it to Jim or to give it to Austin. Okay? So now it's been done. Well, that's actually it's a reroute or delegate. That's a slightly different one. But internal capabilities would be, do it for me. Compute it and do it. Send it off to that service. Have it done. So what you can do is have manual capabilities, internal capabilities, external capabilities that you have represented. You can reroute or delegate to other agents you know about and other services you know about, or you can use technologies to plan and execute a composite of those. So like web services composition, technology will be a subset of doing this sort of thing. And then the idea is it also can receive reports against these things because it kind of knows what's going on, remember, if you get all this now supported by software technologies. It can understand reports coming in as reports on the structure of what's happening. So instead of just getting chat over something, you can now start to see structure in what must be being reported, and you can encourage the structure to be done. So you can help people make sense of this reporting environment and what's going on and control it. And the idea is it should be able to cope with a partial knowledge of this environment. So if you have no knowledge at all, it can still help you track all these things. It just treats them as conceptual entities of these types. Whereas if you have knowledge of these things, and you have understanding of some of that planning, and understanding of what the constraints mean with respect to one another, then you can assist rather more. So it's meant to cope with partial knowledge of processes, organizations, and systems, but also fall back to the position where it is a 100% catch-all. It will always work because it can always appeal to manual levels. So that's what the technology has been about as we've gone along. So we've put some of this, that's the technology sidebar. So we're now going to look at some of our own work and our own projects that have been putting that to use. And this is just a few examples. A couple I'm going to mention. I'm going to give you a couple of slides on each of these as we go along. So I'll just leave that up a second to give you a flavour of what's going on. But a lot of these have been funded through DARPA programs in the US, Defense Advanced Research Projects Agency. They've been in the Planning Initiative. They've been in the Agent-Based Systems community in the semantic web area. So they tend to have a flavour of rather rich semantic models underlying collaborative task support of various kinds. But the first one is actually a grid-based system that's intended to support researchers working in grid-based computing and the way they collaborate together in rich message, rich media environments, rich meeting environments. Okay? And that's going to come back when I talk about iRoom at the end of this project, because it's kind of an early example of what we were trying to do with some of the technologies I'm going to bring together when I show you the iRoom. So let's go on to that first. This was part of the Advanced Knowledge Technologies program in the UK, funded by the Engineering and Physical Sciences Research Council. This is a number of universities working together in Britain. And what they were looking at for a period of 7 years was advanced knowledge-based technologies. Halfway through that period, the semantic web came in, and that is really an extension of what we were all trying to do. So this idea of a rich web of systems that you could make use of, and systems that could introspect and understand their own knowledge. So in particular, there are a number of tools brought together. One was the compendium tool from Verizon in the US and the Compendium Institute, which is a brainstorming GIBIS kind of tool, but not a lot of structure in it. It's intended for flexible brainstorming, and as usual with these things, it's kind of the PowerPoint replacement for the world of brainstormers. They really want to use whiteboards and things, and they're always slowed down with technology typically. These things have got to be rapid, fast. Let me do it. I don't want to. No, I can't be structured. Don't slow me down. It's got to be that kind of tool. Compendium was designed to be that. Then there were some media capture tools that let you capture the many threads of a meeting and the different technologies used. The PowerPoint presentations, the audio, the video, the talks going on, the other notes made, or chat made. So you capture these threads. There's a number of tools like this around in the world now. In fact, Edinburgh has a project called the Instrumented Meeting Room, Steve Reynolds' project, that's actually very, very similar. Its interface looks very similar to what was going on here. But this was Southampton University's media replay tool. And it's about synchronized media. It's about understanding that you can go to points and say, when Austin was at slide 6 and a question was asked by the audience and he dismissed it as an irrelevant interjection, why did he say that? Because I felt I was telling him it had already been done 20 years ago, right? So somebody who wants to know about that later, and then they can go, and and that was said, I think Austin just misunderstood the question. It was clear now. Okay? So that's the kind of thing if you were trying to do this replay. It's very good at doing that. And the tools were all linked, so you could automatically go to these points and replay them for people who were there or not. Then we're using IX technology for intelligent to-do list management and action management in the meetings. And all these were placed together alongside a semantic web tool, which was about finding experts in a domain of interest. And now we were, for this, using the science information base from the research assessment exercise in the UK. So there's something like 16 million facts about science in the UK stored in this database. It was all mined to become triples in a semantic network database. And then this tool, CS Active Space, which won one of the semantic web competitions 2 years ago, was about giving you an interface to scope the question you wanted to ask. And ask things like, if I wanted an expert in a certain field, let's say hydrology, 100 miles away from Edinburgh, because I have a potential with an oil spill in the Firth of Forth, who's around, who's available? So you could bring together scientists and people with an interest in a certain area. So this is a question where we're asking about computing scientists in this case, within 100 miles of Edinburgh who have certain attributes. So it's about looking that up. All these were linked to create this advanced knowledge tools area. And it was used for several things, including just scientific meeting support. But one of the things we used it for was an industrial accident scenario of oil spill, where the idea was you stood up an emergency team that was put together dynamically by finding the people who were going to do the response, the people who were out there putting the booms down and the other things, getting the physics and everything understood, but also going and finding the scientists who could come onto the team to give some of the advice needed about where the oil would go, what the weather would do, what would happen in the Solent, because it was around the Isle of Wight, this particular thing in the south of England. So you can see that there's a nice sort of set of technologies all brought together there. Another scenario on AKT was a plane down scenario, a cargo plane down scenario over central London, where it takes out some of the infrastructure around London, in particular the hospitals, and some of the routes are blocked. And the idea is to deal with an emergency in a disabled city situation. And that made a nice example of some of the problems of doing this. It isn't that you can be pre-planned, in other words, because a cargo plane coming down and taking out a major hospital will clearly change the way you would have a normal response plan in terms of things. So it's meant to be a disruptive kind of a dynamic event, and that's what interested us in the research. This was actually based on the Kobe earthquake simulator that many of us in the AI community use every year as a competition, and it came out of RoboCup Rescue that you heard me mention before. So it's an annual competition to encourage people with software technologies to try to show their technologies in these collaborative systems. And we based the London scenario on the Kobe earthquake simulator. This is the Kobe earthquake simulator, an early version of it. So it's quite simple in terms of its graphics and so on. A little bit of animation of it, but not, by today's standards, not superb or anything. It was just meant to be enough for scientists to do their work. But you have the earthquake occur, problems occur, fire is spreading, people are injured. If you leave it, it gets worse. And a lot of Kobe gets destroyed if you leave it. And a lot of people did die in Kobe. And a lot of buildings were destroyed, a lot of industry were out, chip production was down because of all the industry that was disrupted. It was a big, big event. And the idea is, could you have done better by better coordination, using knowledge-based coordination and social networking? So we use IX into this competition, into this simulator, and we try to have the command centres, the police centres, the ambulance centres controlled by IX technologies, or some of them, and we deliberately don't control them all, so we assume we're working with other technologies or people in other areas, so we don't take over the whole solution. We don't try the whole solution. We try to do a partial solution working alongside other technologies. And we had a PhD student, Clarendon Siebra, who looked at IX in this context and had these agents basically then controlled through IX. And some of the results are quite staggering if you're able. This is in a disabled environment, remember, so you assume wireless communications are slightly out and some things get through, some things don't. So generally speaking, you're entering a competition in a kind of semi-realistic version of this. And the idea is to do better than real life in terms of what happened with the number of people dying and so on. This is the more recent versions of the graphics simulator for that, just to show you, now using more virtual worlds and gaming technology. But it's the same kind of thing. Open knowledge is the other large project we've been involved in Britain and Europe in the knowledge systems area. So as well as AKT in the UK, AKT was year 2000 to year 2007, finished in mid-2007. Open knowledge started in 2006 and will go on for 3 years. It's an EU project, European project, with the universities there, Amsterdam, Barcelona, Edinburgh, the Open University in the UK, Southampton in the UK, and Trento in Italy. And this is the e-response element of open knowledge. It also has a bioinformatics element. So it's about using peer-to-peer networks to collaborate in these areas. So a lot of the technology is about peer-to-peer collaboration now. You form peer-to-peer communities and what they can exchange and how they can work with the processes and the communication methods between them. That's the research. Then it's applied in these two areas. And as you can probably see with the rather small lettering over on the right here, we're bringing in a range of kinds of disasters. The metropolitan accident scenario I just mentioned in terms of London is here. There's a fire grid. I'm going to come back to fire grid in a minute. So that comes in terms of large-scale building fires. And we were kind of looking at this area in the Open Knowledge project. But Trento is looking at flood response in the Trento basin of northern Italy. So this is an accident, not an accident, a natural disaster that plays out over a longer period. Typically is a 3 day to 1 week kind of issue. And you this doesn't do it. No, this actually is the real responders. Yeah.
Is there a Katrina?
I haven't seen data for.
Anywhere for a feature analysis?
No, I've not seen that. I'll come back to what is captured in terms of available to the research community. Some data, and that does include things like the tsunami on Boxing Day 2004. But I'm not aware of Katrina data being available for researchers. I'll come back to some of that data availability because it is interesting. So the Trento area is our colleagues in this project looking at the flood response in that area. And we're looking at projects now that actually do mix these kind of lower tempo but still very disruptive emergency responses, overlaid with high tempo events which occur while you're responding. So you're in this kind of disabled environment because of, let's say, floods or fire or natural disasters like hurricanes. And then you still have medical emergencies. People are still having babies and still having problems with that. People are still having accidents in the home and fires in the home and so on. So this is the flooding scenario in Trentino, as they call it, the Trento basin. So it's kind of a thing that can occur at any time, but well managed, it can be less of a problem. Yeah.
So what are the computer demands for like the code scenario? You get how fast does it react to decisions? How fast does the agent
In terms of the simulator, do you mean?
Well, yeah, I mean, or just get real data out to real people.
simulation aspect, and there's data from the real event. Which are you asking about?
Okay, let's do the simulation.
The simulator, over the years, the simulator was written by Milind Tambay and his team over at Stanford. And over the years, it's been improved as it's gone along. It was initially funded by DARPA and the United States Air Force. And it's USC. I beg your pardon. Sorry, Milind Tambay is a USC. So Milind and his team created that scenario for the community to try to help people target their collaborative, shared planning, command and control type technologies to that. So it's to encourage them to be involved in emergency response and other kinds of dynamic events. The simulator's it's been growing as it's gone along, and it's now got a community behind it that itself has competitions for how good the plugins can be. So some of those graphic plugins you saw, for instance, they can be competition winners now by making better simulators. So the simulator obviously is a very limited thing. It's meant to just do enough that you can communicate with it, tell it to do events, yet it's running with a tick going on at different times. Now that's a simulator, and I don't think in a sense that's interesting, because obviously the simulator could be as rich as we chose to make it. If what you're saying about is about the environment and about what happened.
In your software, look at what the simulator is projecting.
Right.
Right, and make a decision on what it should.
So what you're really probably asking is, can you get ahead in real life?
Right.
Right. I'm going to come. So let me just hold that off for a moment. Don't let me drop it though, especially if we come back. If we haven't referred to my questions, I'm going to mention FireGrid in a minute, which is designed to get ahead of it in real situations, and has already shown we can get ahead of real situations like the Twin Towers collapse. So I'll come back to that. Because I know a little bit more about what the real fire simulator is doing there, whereas I'm not a fire simulator person, but we are using fire simulators in the command and control systems I'm calling fire simulators, which are meant to get ahead in predictive sense now of a fire. That's not what the Kobe and the London earthquake and the London scenarios were about. They're more about a world as if we are executing. That's what those simulators are for. Just like a virtual world might be, to show your technology in an environment that is a demonstration of what it would look like if you tried to do it in real life. That's a slightly different thing, as you're well aware.
Are these stochastic environments or are they deterministic?
No, they're not deterministic. These things typically do have stochastic layers. Our own, even going back 15 years, our own simple systems had two levels of probability involved in the events which could occur and the way they played out. Just even with things like the Pacifica domain, if you remember the work that went on with the fictional island in the Pacific, which was for emergencies occurring and non-combatant evacuations. There was all sorts of stuff, even to the level where truck tires blowing was probabilistic. You know, when you thought you were sending a truck to pick someone up. Weather patterns were probabilistic and so on. And there were two levels of this, even in the very simple simulators. Yeah, correct. So some of it is about, for instance, planning, not knowing what's going to happen, you know, in terms of the world, because it's meant to be a surrogate for the world in the case of those. That's different to the simulators, which are an analysis aid to predicting what might happen, let's say to fire spread in a building, because you want to make sure your responders aren't in that part of the building when it collapses.
And how reactive can your intelligence be?
So the idea is that if you could ask the right question of that simulator. Now, I'm coming on a little bit to FireGrid here, but let me just say it in advance. If you were able to ask a good question of the system, and it could give you answers in a form you could then communicate to a person who could change it or make his decision on the basis of that information, you'll have a very good system. FireGrid is exactly about trying to do that. Can you ask the right question of a simulator, which, if you gave it the right question, would have enough knowledge from the sensor grid and from the simulation knowledge and from the knowledge of the fire spread and knowledge of the building to get ahead of the fire? But you've got to ask it the right kind of question. It can't just do everything. It can't do a 10 million, Monte Carlo simulations. So ask it the right question that could make a difference to the decision the responder's about to take, like whether to send you and me in through the left door or the right door, and it might mean life and death for us. If we can get ahead of the point where we say one will work and the other won't because of this reason, and we persuade an emergency responder to say go left then, and it's the right decision and we don't die, then we've been successful in FireGrid. Okay, so FireGrid. I've nearly told you everything you're going to see on these slides. Its mission. This was a project that was conceived a number of years ago, and when it was first bid into the UK's e-science programs, all the reviews of it were that it was the best of the project proposal that's seen, but way too challenging and way too likely to fail in its aspirations to be funded immediately. But they'd love to see it funded. And they found ways to fund it, but they had to be novel ways to fund it because of the complexity of the work, the interdisciplinary nature of the work, and the risk of doing the research, even at this stage, for a research community. So it gives you a flavour of how researchy it was. And people on the review panel were people at CERN and other people who knew their job and were willing to fund risky research, but understood that we really were going out on a limb with what we were claiming to do. And even some of the claims made by my own colleagues in meetings, I simply couldn't believe what they were claiming in sciences I wasn't a part of, remember, until I went back and talked to them and got the explanations of them, because they sounded quite incredible. And that's been the exciting thing about working on the project. We've got some of the best fire modelers in the world, some of the best AI people in the world, some of the best engineers, some of the best grid scientists, the best sensor grid people, wireless sensor grid people, and so on. This is the big aspiration stuff, in a way. But if it's partially successful, it'll make a difference. So what we found we had to form a club first, because it was so risky. Nobody believed it could be done, except the people who were saying that we ought to get on with it and just do it now, get on with this. We formed a community club of people in the response community, the engineering companies who design response systems in buildings and in the environment, and real emergency responders, real fire people, the Deputy Prime Minister's office in London who had to politically make it happen. A number of people came together to do this, and a number of universities. And when that club was formed, it quickly then got behind the proposal to make sure it could be funded. And the initial funding now is a project that's underway for the next 3 years. It's been going about a year. Just to show you the kind of community that's in this is the fire grid network, the people involved. And you can see it's everybody. There's lots of people. There's 3 fire brigades. We even have people involved in the New York Fire Brigade as interested people. There's 3 of the real fire brigades in the UK who are working actively on this in terms of giving us procedures and support and looking at the interface and so on. The Fire Safety Services College here. But then you've got people like ARUP in Europe who are the people who design fire engineering systems inside buildings. You've got the Building Research Establishment who lead the project now. You've got software suppliers. We also work with the supercomputing centres in Edinburgh and Singapore so that we can use their supercomputing systems, and they're providing codes to make supercomputer versions of the different fire simulators we do. The fire team itself are the ones that have done investigations like Piper Alpha in the North Sea, who were part of the NIST team that modelled what happened in the Twin Towers collapse and showed they could get ahead of the fire with the simulator codes that already existed. They did the London Underground inquiry modelling. So we're talking about very serious group of people here, all sorts of interesting things. Our role in this is to provide the C3I system that communicates what all these systems are doing to a responder outside the building, in terms of the fire chief or whatever you want to call it, the person doing that. So the technologies themselves, they're working on wireless sensors, an idea of tens of thousands in things like nuclear power station, wireless sensor grids. They're working on super real-time simulation on grid computers, the storage of maps, models, scenarios and other things which are securely stored and only available for certain limited purposes. You don't go away giving where your safety equipment in a nuclear power station is to anybody. You know, these things are secure data only to be used for certain purposes at the right time. And then you're also dealing with the responders and the C3I systems we're working with, command communications, command control communications and intelligence systems that we're doing. The idea is to put together this as an organisation that can support fire decision making.
Wait,
Yeah,
back up.
yeah, sure.
So you talked about the security implications
Mm.
of nuclear power facilities.
Yeah.
Presumably that's not only an issue for, like, your simulations are well and good, but we're not going to release state secrets to you to make a sim.
Yep.
It seems that there's some interesting opportunities there too, or some interesting obstacles around, yeah, we understand that there's this big, event that's happening over there. If it's actually occurring, we're still not going to release
Yes.
loads of our data to you.
Yes.
So you have to model parts of that system as a black box.
This is absolutely right. In fact, many of the coalition kinds of environments, almost any collaborative environment, you have to persuade people in many cases to release data. But then you have to persuade them there's conduits by which they can release data, so it's only used in the circumstances you allowed for.
So,
And some of that occurs all the time with coalitions, where you don't necessarily want to give away the quality of your sensor, for instance. If you're giving me, let's say, magnetic anomaly data about the Red Sea, let's say I've got a better instrument than I want you to know, but I do want to help you find your sunken submarine. Well, how do I do that? So some of the technologies I'm not going to talk about here, we have worked with our colleagues, Jeff Bradshaw, others down at IHMC, for instance. These guys work on all sorts of ways that you can semantically encapsulate things so that you can only give away the element you want to in terms of the quality of the data without necessarily giving away absolute raw sources. But there's just so many research issues in these areas, you see, that's the thing. But it does come up all the time, and this issue of how can I give something to you in a secure, organised way? People are going to have to get real about this idea that you can't just assume that, you know, every map and every... If you saw this building, you know, you wouldn't necessarily want to give to everybody where all the fire protection systems in it were. Yet that's kind of an assumption of some of the simpler systems, that you would just go and you would have all the data. But you imagine if a terrorist was given that information, they'd know exactly where to go to just take one or two things out, and then they cause the grief. And if they know your egress routes, they can actually have a secondary bomb ready to go as soon as everybody's just got there. So this is a very serious issue. However, remember, I'm not talking about necessarily making progress on everything here, but this is the vision for FireGrid, and some elements of that are being explored. So IX itself acts as a C3I interface onto this. The interfaces of, I mean, this is really what they want. They want red buttons. I mean, they want to know whether the status is red or green, really, when it comes down to it. Now, what we're trying to do is look at ways you can present actions for the options that you may be exploring for the decisions you're going to take to fight the fire. That's really how we're presenting it underneath this. So it's very IX-y in terms of its orientation. But then the particular systems that we do have to be realistic at the moment to just do the best we can to draw out of these super real-time simulations and other kinds of grid services that we're running.
On the scope of this project, I could see time constants being such that large multi-day forest fires, jumping roads and threatening large residential areas would be amenable to the idea of people sitting around and actually putting enough of a model in place to make it valuable, and even defining actions to make this valuable. For a single building burning or a couple buildings in a city, unless you really believed you could adapt templates quickly without putting a lot of effort into like really getting down the actual model.
Right. So I think you have to. So you have to kind of look at slightly different context now. Imagine a situation. Take Tokyo. When you go in from Narita Airport into central Tokyo, you go down, you see all the buildings. They've all got the tape on a certain window as you drive down. That's because someone has decided those are the windows you're going to do the egress through for fire escape. Why can they do that in Tokyo? Because they have earthquakes. If you were in San Francisco, I'm sure something similar probably has to occur. You are in an area, in other words, that demands that you have to think about that in advance. Now, I agree with you in certain other areas, you can't do everything. You can't afford to do this. But you imagine a new modern building being built 10 years from now with protection systems that are intended to save the building and its occupants in rather extreme situations. The models will be there. The 3D models will be there. In fact, the systems would be designed with a kind of another version of this, which we are going to, I think, I'm not sure we're going to talk about it, but this is also designed for preparedness and for design phase, as well as for training phases, as well as for real phases. So it also is used, in other words, for during the design, during the training of all those evacuations and the emergency responders and so on. So
that's a whole.
But that's part.
I would expect you to say slide one of the major uses of this is a design tool to be used with the architectural people building buildings.
So that is an element.
That didn't work. Let's try a different building design.
Yeah. Well, partly. I mean, it's mostly to do with.
All my Sims get caught on the way into the bathroom. So they can't work the doorway.
Well, I mean, some of that flow analysis is, of course, done as well. I'm going to move on because actually, I have one slide on IX at the end that actually has that preparedness and so on issue, but. You're right that these things are intended for the next generation of intelligent buildings, which themselves are designed with these principles, where the supercomputers aren't in the basement, and you don't pay for the supercomputer as part of the building. What you have is a helpful environment in which those supercomputing services are available because you've been a contributor to the helpful environment and can call on international, not just national services, to do the super real-time simulation using perhaps a tenth of the world's computing power on demand. But how did you get that? How did you get a tenth of CERN, for instance, on demand? You got it because CERN has 20% more computing power than it can afford for CERN science, in order that it provides some of that element back on demand when it's needed for a major fire in an American tower block. But that's why the helpful environment is about sharing those things, sharing those services, and understanding that some of you are a contributor occasionally and some of you aren't. And some of you are specialists and provide your specialisms when on demand. You don't try to provide every service in your own organisation or in your own country indeed. And we've done a little bit of work on safety and companion robotics. I've mostly done this with student projects. This is Appleton Tower, where we're based in Edinburgh. So we do have little projects which are to do with small teams. And the small teams we use IBOs, Sony IBOs, but the small teams of people, robotic systems and sensor grids, intended as a kind of a demonstrator of what would happen in a typical building. And we just have small numbers where we have a little bit of team organisation between the robots and their specialist capabilities, a little bit of organisation on the different kinds of sensors, and then we have people involved. And the idea is put together the team to try to respond and to try to check that students are out of rooms and send robots around the corner when you're out of wireless range. It's just a little excuse to do some of that exploration. We've also looked at robotics, a project that didn't get funded, to do with home-based robots for helping early phase Alzheimer's patients so they could live in their homes longer, using a robotic agent, companion agent, and a sensor grid. So it's very similar to this in a way, but for home robotics. I'm on the scientific advisory board of GOSTI, which is a French company that does the URBI environment, which is a Universal Robotic Behavior Interface, which was intended as a layer of this. So IX talks to URBI, which can then talk to the different devices. And this is going to be the basis for the new RoboCup League robots. They're going to use the Aldebaran now, if you knew Eric. So now the Sony IBO isn't made any longer. They used to use this. So it's going to be now URBI talking to these biped robots called Aldebaran Nows. And we're going to be getting one of the Nows, we believe. So COOPA. I'm going to just rush forward a little bit because I want to get to the iRoom stuff before we run out of time here. This was our recent project. It finished just a few months ago. It's with the United States Joint Forces Command. It's about personnel recovery and looking at personnel recovery offices that you set up, agencies you set up when you have a multinational mission or a joint forces mission. And we did some of this work with folks at US Joint Forces Command J9, which is their experimental J, and Edinburgh and Open University, and with the Compendium Institute people like Al Selvin, who are the GIBIS people. So this is a typical rescue centre, actually. What they have is a desk in the middle with a guy coordinating things. He's got colleagues around him. He's got whiteboards and he's got computers. So they've got, there's a Windows machine running here, secure one, and it's got on it instant messenger. It's got net meeting style stuff on it. The versions I saw all have net meeting. And what you've got is a director in the middle, in other words, a guy looking after the whiteboard, in particular the incident board. That's the issues or the events coming in, the problems that are occurring. You've got a controller who's taking decisions about where you place your assets on the map, deciding what helicopter to use. And you've got staff who are acting as communications, both for faxing and emailing and instant messaging across the other agencies outside this office. That's what a typical rescue coordination centre looks like. This is me sat in one, and you can see that it's just whiteboard-based stuff with a computer to the left there, which is rated secret, so you can't see it, but it's just off to the left. This is our own centre. This is just a three-screen projection system that is our own command centre at Edinburgh, just for simulating these things. That's some of my colleagues on COOPA, and we're using some of the tools like Compendium, IX, and so on here, talking in an exercise we were involved in. The role of IX in these systems is to support communication, the organisation, and communication of search and rescue components. And it was putting the organisation together, helping you maintain it, and then communication between them. It uses Inca for shared model between the shared task-directed communication between them. And the idea is it just really allows for the refinement of plans in this framework. This is the slide I was mentioning. IX is used then in modes which are to support a design time phase, where you're designing the procedures, you're designing those whiteboards. It's also used for training. And in fact, recently we've been aiming our technology at training establishments in the military and in the civil response kind of communities, because it's a good way for us to show our work and get it into use and actually have it make a difference without us having the ability to design that system to be robust enough for real deployment. That would need That would need folks like you to do it. We can't do that kind of work. Response mode is then about, obviously, acting in this response kind of community. So in the Co-op project, we were kind of supporting all these things with IX technologies, linking to other collaboration and communication technologies, remember, which I said we assumed. But nonetheless, we were doing all these things. Supporting chat, structured chat about plans, very important. And that's what I'll be talking to some of you about this afternoon. Information sharing, task support, these to-do lists and so on, whiteboards, map boards and so on, all supported out of this common model. So helpful organizations that are already around, this is some of the pictures from the response to the Boxing Day tsunami, or Boxing Day 2004 tsunami. So you've got all these sort of responses going on from the military to support the civil agencies. The multinational planning augmentation team is a team that's been around a few years to do that. It's about 33 nations now with interest in the Pacific Rim. And what they do is train together to help respond to disasters. This is the kind of thing they get. They create, as soon as a disaster occurs, they create a virtual operation center based on the web. They have a little tool, in other words, that lets them create a website, which is a collaborative website. They also create a number of rooms, which are rooms for looking at assets, dealing with areas of emergency and that kind of thing. This is the Leyte mudslides virtual operation center a little bit later, the Philippine Leyte mudslides area. And you can't read this, but on the right-hand side are the collaboration tools they allow, and they're all open source tools there. So the idea is, because remember that there could be 100,000 people involved in some of these, so you need tools that people can basically click on and use. So they go to this, they click on it, and they can have chat, they can have Skype type, instant message, voice over IP, that sort of thing. And we're wanting to fit into this kind of collaboration tool environment where you can go in and get the kind of to-do list and plan support. This is a command center for Tokyo, so this is the Tokyo Response Agency. I won't show the detail of this, but basically they've got a back room that's driving what is shown to the room on the top left there, which itself is where the mayor of Tokyo would sit and his military and civil advisors and his team around him taking decisions. They're deciding what goes onto the board in terms of decision-making information. So it's this kind of environment we're interested in, and also mobile versions of this. These are the Titan trucks built by Titan Corporation in America, which are the mobile command centers they sell to FEMA and others. And this is the UK equivalent, the brigade command units. They're sold in the UK by Dennis. So this is the kind of mobile or fixed infrastructure we're wanting to target our technology towards. The other group that I wanted just to mention to you is in Washington, D.C., which is a project called CAPW, the Capital Wireless Integrated Network, which takes an area of the beltway around D.C. and puts Jabber-based XMPP-style instant messaging onto the cabs and into all officers involved with responding to an element of that beltway. And it's all the military and all the civil responders who respond there. And the idea is to communicate between them all, allow them to communicate between all those wirelessly using messaging systems in that area. Again, we would see ourselves as trying to fit into this. In fact, I spoke to the architects of that group. It was already a well-advanced project, unfortunately, by the time I did. But I would have loved to have got an IX layer into what they were trying to do, because we can already speak all the IX protocols over Jabber XMPP. So this... I'm not sure what the specific technology is. I do know they use, because remember, by saying it's XMPP at the protocol there, I don't understand I don't know the physical nature of how that's done. Yeah, so it could be cell phone, it could be satellite, it could be all those things. As you know, I don't know. I just know that it is XMPP at the protocol level, I'm afraid. Right, so sensor data, these are some of the kind of needs of these organizations. So this is just the final slide on these helpful organizations. You can see that a lot of this in the middle is dealing with requests, matching that to capabilities, doing the brokering of that, standard operating procedures and alarms, planning coordination and so on. But it has to be done at a scale and with a level of robustness that really will work. So, yep.
Has anybody done evaluations of all these systems? I just hate to even imagine what happens when a CAT technology, for example, is brought up with a big knife switch in a real emergency.
Yeah.
The heck is this? How do you use the coolant? Who am I talking to? And do these actually help? Do they work? Do we know the evaluations done? I know we're all very hopeful that IT will be very useful.
So the CAPW project was initially an academic project, government and academia working together, and then it went into become a deployed It is it's a real deployment, but in an experimental way, in order to measure effectiveness and other things. I do know that. What I don't know is the outcomes of that. But if you do go to the capwin.org website, I think you'll see that they are serious about the evaluation of it. That's why it was put into use. And it was just an area deliberate for that purpose. And they made sure all responders had it so they could kind of understand what they did and didn't gain from doing that. Right, virtual worlds technology. This is the final part of the talk. I just want to bring this together to show you how a lot of this technology, these ideas all come together in this idea of an iRoom. So we're working on virtual worlds for work, play and help. Help being the assistance emergency side. Principally I'm trying to hint at that. But also for help desks and other things in fact. So we've been doing this over a period of about 5 years, but most recently because of some of the advances in the quality of the virtual world environments you're now starting to see. These are now practical things. You can easily get onto them. You can have anybody log in, essentially free with them. So long as they've got a reasonable graphic card now, pretty much anybody can run that straight off the laptops. And new clients are appearing which let you stay in those worlds even when you're away from high-performance computers, like cell phone access into the virtual worlds. So you can now start to see them as a way you can organize things. That's why I'm interested in them. They kind of provide a 3D view on the internet. They're just another way of getting beyond a 2D view on internet. But they bring in lots of other things, like social networking. It's a way of integrating these. Instant messaging, agent presence, and maintaining understanding of other people's presence and other agent presence. Linking in web services and presenting that in a useful way. Semantic web access, teleconferencing, voice over IP. These are just more effective ways of doing what we were doing already, in other words. And just it's simpler, they just work, you can go in there, you don't have to remember lots of technologies is the idea. And obviously this will merge gradually, but this is roughly what's going on. Collaborative systems, content creation and management, community knowledge, intelligent agents, and so on. So all of that is why I'm interested in virtual worlds. They're just a way to kind of deliver that kind of thing. And especially because what I'm dealing with generally is distributed collaborative systems. You always need some way of acting as a point of presence for the people involved in a collaboration or in a mission. And that's why you saw the MPART people make that collaboration center. So everybody can go to the website and use that as their point of access to the collaboration even when they're not physically all meeting together in a tent somewhere at a particular mission. These pictures are a little dark in the room here because they're taken in the Second Life viewer. So the University of Edinburgh does have a presence in Second Life. There's a number of islands there. These are, as I say, a little bit too dark. You can't see Carlton Hill and the castle in the mists of the distance here, but let me assure you that's there. There's a lot of departments at the University of Edinburgh in this thing we call the virtual University of Edinburgh. That's some of the avatars, the motley crew of people who are working this. We just had a little photo shoot to get a few of them together. There's something like 90 to 100 people now involved in the virtual University of Edinburgh, so it's running alongside the real university. And they make all sorts of uses of it, which for those of you who are watching this talk offline, you can read that a little bit slower. And there's a website, vue.ed.ac.uk, that gives all information on the work the university is doing. These are the islands that we've got. A little bit of informatics there. That's the AI2 office in Second Life. And this is my corner, which again, you can't see too well in the room here, but these are some of the collaboration centers. There's various ambulances, there's smoke going up there, you can't see it very well, I'm afraid. But this is our little corner of an area that we use for these little setup scenarios, which are little training scenarios to try out our systems. And in particular, we use this iRoom idea. So let me take you back to the MPAT slide. Remember I said that they set up these rooms, these chat-style rooms. They share assets in those rooms. They use them so that you can get into specialized areas to do function-specific discussion, typically, about the maps or about the area, about the problems occurring in a particular part of the emergency, but quickly allow you to access web resources and other collaborative resources. Go on to Skype and chat, whatever. See a bit of video, whatever's needed. Take the cell phone images in, try to make sense of them, run the simulators. That's what they're doing through all of that. We're doing the same. So the iRoom lets you set up very quickly in a virtual world like Second Life or other virtual worlds. We're looking at others now. So the idea is you can set one of these collaboration centers up quickly. It has zones where you can set up function-specific rooms. You can set up the teleconference links to the outside world so that you can be dealing with real meetings or bringing other people in internationally. So this is my room in Appleton Tower, linked up to a room in Second Life where I've modelled the table just so it looks as if it's a mirror image of the thing. These telepresence ideas, in other words. And then once you're in there, the idea is you can share resources. And we're doing that with a number of projects for play, work, and help, as I said. We're working with a games company on using this as a games front-end lobby. We're working with that same games company on using it for the process of creating video games, where you're having to deal with lots of media producers, music producers and others. So the collaborative process of producing a product, in other words, is something else we're using the iRoom for. We're using it, sorry?
I'm a little unsure what that image is actually showing.
That image is in Second Life, so we're looking at the Second Life screen. These are avatars in Second Life. We have a table here. There's a little simulated Polycom style phone there. That actually has in it the link to the IX technology. So that phone is acting like an assistant to the room, and it's listening to the conversations in the room. It's acting to support the media screens. It's acting to put things up on the agenda or onto the media screens for you, and it can take action items and things and relay them to the IX system. So that's all going on this side. On the other side, that screen there, I'm showing a real-time feed of data from a real room, which has got collaborators in it, but we're not in Second Life. They're in a real meeting space. So they, on that side, if we were on that side, that's me sat there, I can see everybody who's on this side of the screen on a screen that's identical to that in my office.
Right, okay, so then as a viewer of this, I am in...
So you could be joining from your office in Redmond.
So I'm one of those avatars.
If we were centering this on one room, you could imagine it being done around multiple real rooms, but if this was centered on, let's say, a meeting in Edinburgh, this was the command center, let's say, or the meeting room anyway, you could take that empty seat from Redmond and you would join the meeting from your screen, and you would look like an avatar in a screen to us in Edinburgh. And to the other participants who were looking in through Second Life, they would see you joining that seat.
And the guys in the video are just the people who haven't heard about Second Life.
They're the people who they typically would be in. I'm thinking that would be a command center, for instance. That would be where the people were doing the work. They may have the maps on the walls. And what's more, that could be bolted away, of course, like a lot of these telepresence rooms. So that could be 5 of those. We're nearly at the end here, so that's just a blow up of that same picture to show you it is. If you take a look on the brighter version online, I think you'll see what's going on. But this is acting as the IX connector. And just to show you the kind of buildings, this is the one we're looking at with MPAT, the multinational planning augmentation team. It has 8 rooms. It's a very simple shape that has a collaboration center where you can really just use it to tell you point of presence. Who's there? We don't even bother you really sat around a circle. We don't even sit now, people around the table. We just sit them down because you don't really look at the avatar once you're in the meeting. But we then know you're present, or Austin's present, or whatever it is. And that can trigger all sorts of other, because it can be used as a constraint. You can trigger things like saying, we're waiting for you to join in order we can talk about, the project we were doing together or the action item you and I had together. So that kind of thing can be done automatically then through the IX adapter that's running in that room. But you can also use these corners as specialized areas. So you could have the maps up to do with that area of the response, or the portal to the web service that's supporting the simulation and the current state of it. And we could put our attention to that corner and then move our attention elsewhere. And a lot of this has been around for a while in terms of virtual collaboration technologies. This idea of leaving partial presence in one place, directing your attention elsewhere, but then having things tell you to come back, and putting meeting room assistants there. This is the virtual world of whiskey iRoom. It's designed like the whiskey shops, Glencairn Distillery's tasting room down in central London in Paternoster. So it looks very, very similar to that room. And the idea is that it's a kind of a little bit of a fun project, but it's really about tutorial technology. It's about using the same kind of thing to support educational tutorial environments where you want to be able to support a tutor in talking with people who may be now distributed and doing a tutorial. In this case, the tutorial is about the whiskey production process, the regions, and a tutored tasting. So typically, if you went to a Scotch whiskey tutored tasting, it's a partially educational experience as well as a fun experience. And IX, in this case, is in this little block, and it's controlling the media screens, and it's assisting the tutor to do what they are meant to be doing to have certain learning outcomes. And some of our students are working on natural language generation plugins to this to make it more interesting. The balloon going over also has IX technology in it. So the balloon is meant to be something that shows you the whiskey regions of Scotland in an educational tour, but itself is meant to also have some of the knowledge of the processes involved, and it's meant to be able to assist you. So the aim is to kind of have this so you support real whiskey tastings with virtual presence people who have got a whiskey or a whiskey tasting kit and they're joining in, but also to give them an experience perhaps when the tutor can't be there, and you want to give them support from technologies that know about whiskey and understand about whiskey. So that's some of what's going on there. So again, this was linked up to live broadcasts, and I aren't showing a person here, but the idea is you could be showing the live person who's leading the tutorial. So just to repeat, just as a summarise the talk now, this is our vision for what we're trying to do with all this technology. Remember, it's the creation and use of these task-centric virtual organisations to support all of these kind of resources that we could have available: systems, people, robotic systems, next generation intelligent vehicles, build new buildings and so on, new highway systems, new cities. Sorry, I had to go back. In order to put those together into virtual, highly responsive organisations which can respond to these dynamic events, and everything from very local to global scales. And what we're trying to do is to show that we have a conceptual model for how that could be brought together, that could be a long-lived, cohesive model for how you can develop the specific representations you need to be able to do some of these collaboration tasks. And there's a paper available from IEEE Intelligent Systems from the 50th anniversary of AI issue about the first 50 years of AI and looking forward to the next 50 years of what AI could do. And my contribution to that was called The Helpful Environment, and it's a paper there that gives you a summary of many of the projects I've talked about, and a little bit about IX technology. But it's also articulating this vision of where AI could be helpful in the environment that we're talking about here. So thanks for listening. I hope you found that useful. There's some of the links there for additional information about the different projects I've spoken about. Thank you. Yeah.
So you showed this underlying technology in a number of different domains, right? For play, collaboration. Oh wow. Right. So you showed this underlying IX technology in a number of these different domains, and I was wondering about the authoring costs. Like every time you go and want to do a new endeavor, in a new space, like how is that? What's the authoring story?
Yeah. One of the problems with knowledge-based systems is always a problem, always a criticism, a valid criticism, is where does the knowledge come from to have a knowledge-based system? It's all very well having a good architecture and all of this stuff, but where's the knowledge? Partly, you remember when I was talking about IX technology, I said it was important to us that we had a solution even if we had no knowledge. That's actually critical to making these things work. You can't make the assumption that you have all the knowledge either at all or to hand when it's needed. If you're in a vehicle and it breaks down, you may or may not have internet connection. If you don't, you still want your system to assist you. And it may have some onboard systems that can assist you, or they may have failed. I'm thinking of these systems even to the level of what you find on the back of the visor when you flip it down. And it tells you, if all else fails, this is what I suggest you do. Systems designed that way, in other words, would be about what aid can I give you? How much can I give you that's robust technology? What can I put in your wallet? Like the little cards you see from the Red Cross and others that give you these kind of aid. It's about designing well. So the true position has got to be that we'll gradually shift what we do with authoring a lot of this material to a knowledge-based process that's a more manageable process. There's massive amounts of information available in manuals, checklists, procedures, documents. You go to the fire brigade and they've got 15 volumes of material. But it's not accessible to you and me if we wanted to use it today in an AI planning-based system. But it could be. We've written checklist importers for that reason. We can take checklists out of those manuals and bring them in as a rather crude initial process model that could be used. We also try to link to standards. So if you have IDEF3 models, for instance, it's possible to transform them into models that we can use in our plans. If you haven't got those models, where do they come from? The answer is we'd better start going back to roots. So in Microsoft, for instance, if you have your corporate procedures, well, you have corporate procedures, obviously. So where are those? What form are they in? How are they authored? How are they changed? And how can they be transformed on need? Are they in Microsoft Word documents as checklists? Or are they actually knowledge the company has, which it transforms when it needs to a Microsoft Word document to read? But it could equally well have been transformed differently. So if you and me were the corporate procedure people, I'd be saying, let's make sure our corporate procedures are in a form where we understand it's a procedure and it's represented in some standard form, which is why I've been involved in the standards community for this. It better be in a standards form we understand. It doesn't matter whether it's a 1963 or a 1982 or a 2007 standard, to be honest, as long as you understand where it came from and what it means. That's why the ontology is critical. So if it's a schema that you've designed for a particular database that now isn't in use any longer, that's also not useful. So the true answer to this is that it's going to be a change gradually. As knowledge is eventually captured, as lessons learned are captured, these things won't in future just be represented in document form and in reports and things. They will be authored into knowledge that can be transformed, which is then transformed into the report to give to the government or to give to the business or to give to the managing director. It's transformed that way as opposed to authored that way. And then we'll get the convergence, as I see it, between knowledge availability and knowledge-based systems which can make use of that. And we can't be held up on either side. We should be doing both of those together. You can make progress on both. But I'm imagining a world where they do converge as opposed to we wait for one or wait for the other.
I think we'll just take things offline. Thanks very much.
Right, thank you. Thanks for coming on.